Hello students, let us discuss electronegativity in the chapter Classification of Elements and Periodicity in Properties. Let us discuss this concept with the help of an example. Consider the two atoms here which I am representing here B. Let these have a single electron in the outermost shell. So in order to complete the octet, they have a greater tendency to share the electron to form covalent bond. A covalent bond is formed due to the mutual sharing of electron between the two atoms. Just like here, the two B atoms are sharing one electron. So such type of bonding is called as covalent bond. Let us consider another atom A and B. Here A and B have a single electron in the outermost shell. In order to complete the octet, these share the electron between the two atoms A and B. They will undergo a mutual sharing of electron. So it results in the formation of a covalent bond. But the B has a greater tendency to attract the share pair of electron towards itself. That means the true electron which I marked here, the stark mark, are the shared electrons. That means shared pair of electron. So the B atom have a tendency to attract the share pair of electron towards itself. So the electron will be quite closer to the B in compared to the A, because the B have a greater tendency to attract the shared pair of electron towards itself. So the shared pair of electron, that is the electron which is shared between the A and B, because of the tendency of B to attract this electron towards itself, so these electron will remain quite closer to B. Because of this reason, we can say that the A develop a partial positive charge and B develop a partial negative charge. Why the negative charge on B? Because the electron density is more closer to B. So, partial negative charge. And because the electron density in compared to the B, A have lesser, therefore partial positive charge. So because of this reason, the covalent bond now, which is called as a polar covalent bond, because of the two poles which is developed here, that is A partial positive, B partial negative. So from this example, what is clear that the different atoms, when they are combining by sharing of electron, in that case, if one of the atom is more electronegative, then it attracts the shared pair of electron towards itself. This picture is actually, I found that more suitable to explain the electronegativity. Here you can see the atom. This atom is attracting the electron towards itself. That tendency is nothing but what? Electronegativity. So electronegativity can be defined as the tendency of an atom in a compound to attract the shared pair of electrons towards itself is called electronegativity. So, electronegativity, what is electronegativity? It is the tendency of an atom in a compound. What is that tendency? To attract the shared pair of electron towards itself. Shared pair means, I told you, the atoms when they are sharing the electron in order to get stabilized, that result in the formation of a covalent bond. So that is called a shared pair of electrons. And if particular atom have a tendency to attract that shared pair of electron towards itself, that atom is considered to be of more electronegative. So what we can say that greater the electronegativity of an atom, greater will be its tendency to attract the shared pair of electron towards itself. Electronegativity values of different element are not measured but are derived indirectly by different methods. One of the method in which the Pauling scale method is the method which is used to find out the values of electronegativities. When we compare the electronegativity in the periodic table, we can say that electronegativity increases across a period. That means when we move from left to right in a period, the electronegativity increases. That means when you compare the second group element, lithium, barium, boron, carbon, nitrogen, oxygen, fluorine. In this case, we can say that fluorine is the most electronegative element, then oxygen, then nitrogen, carbon, and so on. So that means which is on the extreme right hand side and the extreme top side, that will be more electronegative. 17 group element are the most electronegative elements. That means they have greater tendency to attract the shared pair of electron towards itself. But the electronegativity decreases down the group. That means from top to bottom the electronegativity decreases. That means the element which is on the bottom side, that will be less electronegative. The element which is on the top side, that will be the more electronegative. So when you compare left to right and top to bottom, we can say that electronegativity increases left to right, but the electronegativity decreases top to bottom. So we can say that the fluorine is the most electronegative element because they are on the extreme right and extreme top. So fluorine is the element which is the most electronegative element. So that is the periodic trend of electronegativity. When we compare the values of electronegativity, which is given in your textbook, that is values are given on the Pauling scale across a period. When you compare the values for lithium, barium, boron, carbon, nitrogen, oxygen, fluorine. When you compare the values which is given here, 1 for lithium, 1.5, 2, 2.5, 3, 3.5, 4. So what is clear from this? The fluorine have the maximum value, that is the 4 value is for fluorine. That is, it have a greater electronegativity. But when you compare the third period element, that is sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. In this case, you can find out the chlorine. Chlorine have a value 3, that is less than 4. So what we can conclude that when you compare the fluorine and chlorine, we can say that fluorine have the greater electronegativity in compared to chlorine. So that is, we have already discussed, that is top to bottom electronegativity is decreasing. So fluorine have greater electronegativity than the fluorine. When you compare oxygen and sulfur, you can see that oxygen is more electronegative than sulfur. So the electronegativity, that is increases left to right in a period, but top to bottom electronegativity is decreasing. That means when you check this value, you can find out that top to bottom the value is decreasing. So from this we can conclude that fluorine is the most electronegative element because it is on the extreme top and extreme right hand side. So the other example, let us take a particular example here, water. In water molecule, there are 2 hydrogen atom and a single oxygen atom. When you check the valence electron, hydrogen have single electron that I marked with red color dot, and oxygen have 6 electron in its outermost shell, that is valence electron is 6. So in order to complete the octet, they have a tendency to share the electron and form a bond between these atoms. These bonds are called as covalent bond. So when you compare the electronegativity of hydrogen and oxygen, so oxygen is on the extreme right hand side and H is on the extreme left hand side. So which is more electronegative here? Oxygen is more electronegative. So the oxygen have a greater tendency to attract the shared pair of electron towards itself. So definitely there will be a partial positive charge on hydrogen, it develops, and the partial negative charge is developed on oxygen. Look at here, the atom which is attracting the shared pair of electron towards itself, it develops a negative charge. That's why electronegativity we can say, and the partial positive charge is developed on the other. So how we represent a water molecule? It can be written in this way. The water molecule, here 2 hydrogen, single oxygen, and the bond between these are the covalent bond. And which type of covalent bond? It is a polar covalent bond. And because of the electronegativity differences between the oxygen and hydrogen, oxygen is developing a partial negative charge and hydrogen is developing partial positive charge. Let us take one more example, ammonia. Tell me here which one will be more electronegative. For this you need to check the periodic table. So if you have an idea about the periodic table, in that you can see that nitrogen is on the right hand side and hydrogen is on this side. So which is more electronegative? Nitrogen is more electronegative. So we can say that the nitrogen in ammonia is more electronegative than the hydrogen. So because of this reason, the bond which is formed between them is a covalent bond that is formed due to the sharing of electron between them. So this covalent bond is actually polar covalent bond because it develops, the nitrogen have a greater tendency to attract the shared pair of electron towards itself. So it develops a partial negative charge and the hydrogen develops partial positive charge. So this is a tendency to attract the shared pair of electron towards itself. This tendency is called as electronegativity. So once again define the electronegativity. The tendency of an atom in a compound to attract the shared pair of electron towards itself is called electronegativity. It is one of the important concept in chemistry. So that is all about electronegativity. That means electron attracting tendency of an atom in a compound. So this is all about the electronegativity which we have discussed in this video. So thank you everyone.